So the recording has started like that. So are you ready?
Yeah, absolutely.
You see my screen, right?
Yes, I can.
Okay, good. So when you talk about, we want to look at hypothesis testing and test of significance. So when you hear the word hypothesis, let me just give you the main clue about this topic is that
Sorry.
can you hear me? What is it?
Yeah, I can see your screen, but like it's not notes. It is like your
No, I'm
entire
not
screen.
writing.
All right.
Okay, wait, can you see my board where I read hypothesis testing?
No, I can't.
Wow. Thank God you told me, Jack. I shared my entire screen. Okay. I'm coming. Now look at it now. Can you see my? Of course, I'm sharing my entire screen now. But can you see hypothesis testing? Can you see? Hello, can you see my board now?
Yes, I can see your board now.
Very good. So, want to look at hypothesis testing. So, basically, what we mean by hypothesis is that we are looking at a claim or a statement about a population parameter. A claim or statement about a population parameter. Population parameter like mean, variance, and so on like that. Okay, pay attention to something. Let me just quickly go straight to the point. You see, suppose we want to, because in this topic, you'll be hearing something about non-hypothesis, alternate hypothesis. You'll be hearing those two frequently. So let us assume that suppose we want to claim that the average age of all OAU students is 23 years. Suppose we want to claim that the average age, let me say this is a claim now. We want to claim that what the average age of all OAU students is equal to 23 years. This is a claim now. Now pay attention. You see, with this claim like this, what is our non-hypothesis and what is our alternating hypothesis? Now, hypothesis about claim about a population parameter like mean or variance and so on like that. So suppose we are claiming that average age of all the students is 23 years. Take note that the non-hypothesis means that the average age, the average is equals to 23 years. This is what non-hypothesis. What we have written here is what non-hypothesis. I will explain further, don't worry. This is what non-hypothesis. And what is alternating hypothesis? Alternating hypothesis means that the average age is not equal to 23 years. Now, pay attention. Non-hypothesis always carry equality sign. Non-hypothesis, this is non-hypothesis, and this is what alternate what hypothesis, exactly. Good. Alternative hypothesis, good. Now, the non-hypothesis is that the mean age equal to 23 years, and the alternative hypothesis is that what the mean is not equal to what 23 years. Now, pay attention to something that what non-hypothesis. This is the clue. It always carry equality sign. Don't forget, it always carry what equality sign. Exactly. Why alternate hypothesis? It will not carry equality sign. It can be not equal to, like something that you're having here. It can be greater than or you see less than, but you never see equality. In non-hypothesis also, it's possible for you to see greater than or equal to. You will see equality there. Okay. But in alternative hypothesis, there is no equal to good. So, and pay attention, whenever you have this type of sign, the mean age is not equal to 23 years. Remember that it means two things. Let me give you an example. If I say Quadri's age, if you are trying to guess it, if I say Quadri's age is equal to, let me say 23 years. Now, if your age is not equal to 23 years, it means two things. Is either quadri is greater than this age or less than this age. Are we together? And are we
Yes.
together? So if I'm saying your age is not something, it's either you are greater than or you are less than. So here now, I'm not having two parameters, greater or less than. So whenever you are having this type of equal to, not equal to, this type of not equal to, this is a two-tailed test. What do you call it? A two-tailed what?
Test.
Exactly. It means that what two-tailed means that it can either go greater or less. That's the meaning of two-tailed test. Don't forget that. It can either be greater or less. So if you have this type of thing, is what two-tailed test. Good. All right, don't worry, I'll explain further. Okay. Let us look at another claim. Let's look at another claim. Okay, suppose this is another claim. Suppose we want to test. Suppose we want to test. We want to test if the mean is less than 20 years. Now look at the first claim here. All AU students, their age is 23 years. Okay, suppose we want to test that what the average age is less than 23 years. Now the thing is that what would be the null hypothesis and what would be the what alternative hypothesis? Now pay attention here. What will be the null? What will be the alternative? The null is what? What will you say? What will you say?
The null is
Now
going
pay
to
attention. Wait, just let me explain. Let's go back to this and revise it. Average age is 23 years. Remember, null will carry equality. Why alternative not carry? Now, see what you have. They say that was suppose we want to test if the mean is less than 23 years. So this one less than 23 years, you put it on the what? On the alternative hypothesis. Why am I putting it here? Remember, alternative hypothesis do not have anything to do with equal to. So since they gave you less than, remember, under alternative hypothesis, you can have signs like this, not equal to, greater or less. But this one you can have equal to, greater than or equal to, less than or equal to. Are we together? These are the signs that are peculiar to them. So if you study your claim very well, they say less than 23 years. Since they say less than, you know that is for what? Alternative hypothesis. Good. Then what will be your null hypothesis? Opposite of this, greater than or equal to 23 years. And that's it. Simple. Now, if you observe this type of thing very well, check it out. Check it out. Is this a one-tailed test or two-tailed test? Is this one-tailed test or two-tailed test?
which of it is it? The alternative?
Exactly, yes.
The
If you want to know,
alternative
if you want to know the tail of the test, whether one tail or two tail, is the alternating hypothesis you'll be looking at. Oh yeah, tell me, is it one tail or two tail test?
one tail.
One tail, exactly. And what type of tail is it? Left
Less
tail, right tail.
Okay.
Left tail or right tail. Less
Left
than is only exactly. This is one tail test. One tail test. And the type of tail is what? Left tail. Left tail. Exactly. That's it. So if you hear the word greater than, it should have been what? Right tail test, and so on like that. Okay?
Yes.
Exactly. Now pay attention to something. You see, when we are conducting hypothesis tests, we are trying to do something. We are trying to decide whether to reject non-hypothesis or to accept non-hypothesis. Again, when we are doing hypothesis testing, we are trying to see, oh, should we reject non-hypothesis or should we accept non-hypothesis? Good. I'll tell you how to reject or how to accept. Let us just go. Now, pay attention. If we reject null hypothesis, what do we say? For example, if we reject null, what do we write as our final answer? We say that what? What do you say? If we reject null hypothesis, what do we say? Do you know?
No.
Exactly. We can reject null or we can fail to reject null. Fail to reject what? Fail to reject null. Either of these two. So pay attention. So if we reject, we can put it in different English. So let me just give you one of them. We can say we have enough evidence. We have enough evidence to support the alternating hypothesis. I will explain. And if we fail to reject no, we will say no enough evidence. No enough evidence to what? To support alternating hypothesis. Good. Now pay attention. If anything make us reject this, it means that we have accepted this. So if I reject no, I would say that what? It means that there's enough evidence to support alternative. Yes. So if I accept no, it means that there's not enough evidence to support the alternating hypothesis. So just take it as just take it this way. When we are solving questions to become clearer. Exactly. That's it. Okay. Good. We move on. Now, if you now want to know, if you now want to determine when to reject your null hypothesis, there is something we call alpha. That alpha, we call it what? It has a name. The name is significant level. You see the significant level? It will be the one to point. If you have to reject anything or accept anything, this significant level will tell you. And there are some questions whereby they won't give you. They won't give you. We always assume 5%. Most of the time, we assume 5%. We assume 5% most of the time.
All right.
So just yeah, good. So when you have to know whether am I to accept or reject, this significant level is very important. Now look at this. By the time you are solving now, it will become. I'll just be referring back to all this to become clearer. In our set, someone got 69.98. They did not give the person A, it was B. 69. I see. Go asked about Mayowa in our class, not the male, the female one. 69. In fact, it was close. 69 point something. Now these people are really particular about. You see those decimal points in your manual that they'll be giving you its count. For the manual to give people A for that 69 point something means that your exact mark is what you'll be given. Yeah, let's go. Now pay attention. So if we are dealing with a two-tail test, this is a two-tail test. You will see it now. If you are dealing with a two-tail test, your alpha, you divide it into two here. This alpha, you divide it into two. This for what? Two-tail test. Exactly. But if you are dealing with one-tail test, you will not divide the alpha. If this is left tail, you just leave the alpha that way. Let me say now, you have something like this now. If it is right tail, you just leave your alpha like this. You will not divide it. Okay, so this is what we use to get the T critical value. Good, don't worry, you will get the T critical value. You need to get the T critical value. So that's that. So pay attention. Remember I told you that what, to reject or accept, this thing is needed. Now pay attention. If any of this number that you calculate, your T, whenever it falls in this shaded portion, you will reject. You see this thing? Put it in your mind as rejection region. As rejection what region? You see this way you understand it better when you are solving rejection region. Whenever your T value enters this part, you are going to reject immediately. But if it is here, you will fail to reject. Fail to reject. Same as all other ones to fail to reject. Good. Oh yeah. Let us now go to solving problem. Let us now go to solving problem. Are you ready?
Yeah.
This is how you now understand. Now, pay attention. You see, this, if you are dealing with one sample, you see, there's something we call test statistics. Test statistics. That C I was telling you that if it falls inside this place, you reject it. You see this T critical value is from statistical table, you will get that one. But that C that before here, This is how you will calculate it. This is what we call the test statistics. Now, if you are dealing with one sample, your test statistics, TS, will be what? Mean minus hypothetical value. Mean minus what? Hypothetical value all over square root of your standard and your variance over n. And there's something we call degree of freedom. Everywhere in the world, degree of freedom is what? Even in thermodynamics, degree of freedom is what? N minus 1. I think n minus 1. Statistics, degree of freedom is n minus 1. All right. So let us now solve this question. As I'm solving one question here, I'll give you assignments on one question. Okay, let us use this to solve question. Are we together?
Yes. I want to confirm this TS is equals to mean minus hypothetical value. Okay, but like for the mean, we are not using mu now.
Yes, S bar, yeah.
Okay, and that SBJ is for variance, Abi?
Variance, yes, this variance. If square is not there, it has become standard deviation. Why not count? Okay, let's solve this question. Okay, let me solve this from your manual. I think I have one question from my manual. Okay. This is the question. Should I solve this one? Yeah, let us write it. Next page. Question, example 1. This is on what? If you have just one sample. So let me write the question. They said the daily determination of the octane number. The dimension of the octane number of a petroleum product from a pilot plant during the first 11 days of its operation gave the following results. Okay, so we have 88.2, 86.7, 87.2, 88.4, 87.2, 86.8, 86.1, 87.3, 86.5, 86.6, and 87.1. We'll stop. Verify. Verify the designer's claim that the product will have an octane number of 87.5. Now that these results have been obtained, all right, you can see we are dealing with a claim. Okay, this is the question. Now, are you set? Are you set?
Yes, sir.
Okay, so they said that daily determination of the octane number of a petroleum product from a pilot plant during the first 11 days of its operation gave the following results. Verified designers claim that the product would have an octane number of 87.5. You see, this is a claim that to have an octane number of this. This is our hypothetical value. What you have there is that hypothetical value we're talking about. Hypothetical value. Let me say now, you are an engineer and you are observing the breaking strength of something. If you have a claim that the breaking strength is something Newton per meter, exactly, that will be the hypothetical value. So that's it. Now that the results have been obtained, so we want to verify the claim that this product will have an octane number of this. Now, we are dealing with one sample. So, now pay attention. What do we do first? We'll find our mean. Remember, what's the null hypothesis and what's the alternating hypothesis? What's the null hypothesis? The null hypothesis is that what? Check. What is the time? Check. Let us look at this claim. That the product will have an octane number. That is, their octane number will be equal to 7.5. You know, our null hypothesis is equal to 87.5. That is the mean equal to 87.5. And then what will be the alternating hypothesis? It will be what?
Well, less than or greater than.
No, check it. Check what I did there. Yeah. See when I have equal to, what did I put in my alternative?
Not equal to.
Exactly. That is, the mean is not equal to 87.5. Exactly. This is claim, this is the alternating hypothesis. Nice. Yeah, firstly, let us find the mean. What's mean? Remember, mean means what? You are going to add everything together. So, summation x all over n, add everything together. What do you have? Do you know you can use your calculator to do this mean? Please, don't never do all this thing manually because of time. So, wait, and the type of calculator I'm using, can you do mean on your calculator there?
I would say, bro, add it together and divide it by n.
No, like that's manually. Like, I want to do it so it will help you do your mean, standard deviation, all those things at once. You have to learn it. As me, you are using like my calculator now. I will have taught you, but it's like you don't have this calculator. But try to learn it, okay?
Yes.
Please, before you go to the exam. But me, I've used my calculator here, and my answer was 87.1. You can go and be verifying it. That's my mean, 87.1. Okay, good. Now, how do we find our test statistics? What do we do? For one sample, how do we find our test statistics? You can see the steps I'm using to solve it. So I want to find my test statistics. But before that, remember, I will need my variance now. Abi?
Yes.
Yeah, so let me find my variance. So my variance, using calculator, that gave me 0.482. So calculator make it faster. That's my word variance. Oh, yeah, let's go. So my test statistics, CS equal to what? X bar minus hypothetical value all over the square root of variance over the number of sample you have. So what do we have here? Let's go. We have that CS equal to this 87.1 minus, what's our hypothetical value?
87.5.
Yes, 87.5. All over, we have square root of standard deviation, our variance 0.482 divided by what's n? What's n? 11.
11.
Exactly. So when we solve all these things together, you have negative 1.91. So, and the absolute value of this will give me 1.91. I don't need the minus though. Now, I've gotten my test statistics now. Now, let me now explain what I was telling you that time. I've gotten this, my test statistics now. Next one is that, am I going to reject or accept? Let me now find this critical T. Are we together?
Yes.
So we are assuming 5% significance level. We are assuming 5% significant level. 5%. And this is a two-tail test. This is a two-tail test. If you have question, do you know why it is two-tail test? Remember, look at our this two-tail test. Okay, so this is what we have. Now, let's go. So what do we now do from here? Calm down. Let us find our critical T. Okay, look at the graph here. This is a two-tail test, means that I'm having 5%, that's 0.05. So divided by 2. So what do I have? So I'm having 5% two-tail test or 2.5% one-tail test. Have you now?
Yes.
Exactly. Okay. Well, all these don't even really matter. So what's my critical T? Don't forget, what's my degree of freedom? Degree of freedom is n-1, and that's 11-1, which is 10. So let us go to our, now see what you want to use to find this critical T. The way we find these statistics, this one is clear. After that, we have 5%. This is the most important thing, 5% two-tail test. Get your degree of freedom. If you can get degree of freedom, and what again? You can get your degree of freedom and this significant level, you can get your critical T. Now let's minimize and go to our table. Where's my table? Okay, let me open it. Let's open our table, please. I'm coming. Now look at my table. What is my, now check. What is my I'm coming. So remember that, look at what I'm having business with here. This is my 5% two-tail test. Do you see? Hello, did you see?
Yes, yes.
My 5% two-tail test. 2.5% one day, so it's the same thing. Now, check. Our degree of freedom is 10. Our degree of freedom is 10. So let us see where this one meets. Remember, it means that this is our critical T that we are looking for. Do you see that?
Yes, yes.
Exactly. So it means that these are critical T. So let us go back to our board. These are critical T. Our critical T is what? We got it to be what? 0. You can just say plus or minus 2.228. I think that was good.
Yes.
2.228. Good. Now pay attention. Let me tell you something. Let me tell you what this thing means. Don't cram anything. This 2.228 means that from here and above, and so on like that. From 2 point, it means that from here you have 2.228 and above. It means that if I have anything like 5 will fall on this side. Like, how do I tell you to understand? Wait, hold on. It's just like you're having number line. And this part is 2.228. It means that all the numbers that you'll be seeing here will be falling inside this shaded region. Now, let's go. Look at our test statistics, 1.91. Now, I want to ask you, if from here is 2.228 and above, now tell me, do 1.91 fall in this shaded region?
No.
No. So what do we now say? What do we now say? So 1.1, so what? We fail to reject null. We fail to reject null hypothesis. We fail to reject null hypothesis. Yes, it did not fall in the rejection region. That's why you see, some book will tell you that whenever your test statistics is less than your critical T, don't reject null. And this is what they are saying. If you observe, this one that is there is less than what you have here. So that's why we fail to reject null hypothesis. Now let's go. So what did we say? Now pay attention. We fail to reject null. Oh yeah, let us go back here. We fail to reject null. And remember, this was the designer's claim. This was the designer's claim altogether. So since we failed to reject it, what do we say? You say I'm going to conclude now. You see, I'll say there is no enough evidence. There is no enough evidence there is not enough evidence. There's not enough evidence to reject the designer's claim. Now, look at my English. There's not enough evidence to reject his claim. It means that what we accepted null. Abi now?
Yes.
So we can't reject it because we don't have evidence to reject it. So people can put this thing in different ways. I can also say, okay, we have enough evidence to support the designer's claim. This is another English. Or you say, we have enough evidence. We have enough evidence to what support the designer's claim. Simple. I know, man. That's it. That's it. Is that clear?
Yes, that's clear.
This is for what? If you are dealing with one sample. So I'm sending is it classwork or assignment to your DM now? I have it already. This was the main example is solved for us in class in our own time. So I'm giving you that one as assignment. This was the one I picked from the manual. Okay, this for one sample. Okay, next. Now, when we are now dealing with two samples, that is what the test statistics. What the test statistics for two samples? Whenever we are dealing with two samples, we are comparing two samples together. And what are we comparing? We are comparing the mean of the two samples together. When we are comparing their variances, we'll be looking at F test. But this one is what T test, so two samples. Now pay attention. Okay, pay maximum attention. Now you see, here we are looking at two samples. Now, the type of test statistics you are using, it depends on what you have. What does it depend on? Now pay attention. See, we always test this ratio whenever we have two samples. Before we solve anything, we will look at the ratio of the larger variance to the smaller variance. We first find their variances of the two samples. We now say big variance divided by the small variance. Now, if the ratio is less than 3, if the ratio is what is less than 3, if the ratio is less than 3, we use pooled T test. What do you say we use? We use what? Pooled T test. This is the type of test we use. If the ratio is less than 3, for example, we get 1.91, if the ratio is less than 3, we are going to use pooled T test. Okay. We use what? Pooled T test. So let's go. What's that pooled T test? Now pay attention. This is the formula here. We have TS equal to X1 bar minus X2 bar all over SP square root of So this is the formula. This is the formula. So this is the formula. This is the formula exactly. And what is SP? You see this SP you see here. This SP is called pooled estimate of standard deviation. Pooled estimate of standard deviation. Exactly. And what's the formula to find SP? What's the formula to find SP? Pay attention. Our formula is SP square equal to N1 minus 1 S1 square plus N2 minus 1 S2 square all over N1 plus N2 minus 2. So whatever you get, you take the square root, then you get SP. So this is in fact, this one is the common one I usually see. This full T test, exactly. So learn that. Is that clear?
Yes, sir.
We are going to solve question, don't worry. We'll solve a question. So now this is when the ratio of the variances is less than 3. What if the ratio of the variance is greater than 3? What do we do? Now, pay attention. If the ratio is greater than 3, what do we use? We use what we call separate variance t-test. We use separate variance t-test. And what's the formula for that? Our test statistics now will now be equal to x1 bar minus x2 bar, that's for the two samples, all over the square root of s1 square over n1 plus s2 square over n2. And that is it. So this is how we use our test statistical. So that's it for two samples. That's it. For two samples, that's it. Mm. Mm-hmm. That's it. Now let's solve. Shall we?
Yes.
Okay. So we have F test also. We have F test also, but don't worry. Just take note of this thing I'll tell you. When you are comparing mean together, that's average. When you are comparing average together, we use t-test. But if you are comparing variability or you hear variance, if you are comparing variability or you hear variance, we use what? F-test. Exactly. We use what? F-test. But don't worry, I'll give you F-test. No wala. So let us solve a question. Let's solve a question. All right. What's that question? Okay, example. That example 2. This for two samples. Okay. A farmer used a commercial fertilizer A on a plant and a modified fertilizer B on an adjacent plot to plant the same variety of crop. The same variety of crop. The table below shows the yield of the crop taken from 5 different locations. That's, we are trying to sample from 5 different locations. And what are they? AB 29.9, 11.4, 25.3. 16.5, 21.1. So for the second plant B, we have 26.6, 25.7, 23.8, 14.2, and we have 17.9. All right. Then after that, what is there any evidence to show that the two fertilizer are the same on their level? If the level of significance is 5%. All right, so this is the question. Okay. Are you ready to solve?
Yes.
Okay. So see what we have here. We are having two samples now. The thing is that we are trying to use different fertilizer. Okay. So we are using commercial fertilizer A and B on the same plant. So on the same species of plant. So on this one we use fertilizer A. On this one we use the modified fertilizer B. So there we are asked to show that what is there any evidence to show that the two fertilizers are the same on their level, are the same. So from that word, let us bring out our null hypothesis. Our null hypothesis is what? We are trying to say the mean of A is equal to that of B. That's the null hypothesis. And our alternating hypothesis, the alternative hypothesis is that what? Their mean are what? Different. So here we are looking at a two-tailed test. This is what? Two-tailed test. Now, that's for that. Next is that, check it out. We have this already. So what is the mean of plant A? What's the mean of plant A? If we find the mean, you already know how to find mean now, right?
Yes.
So what's our mean? You'll be having, I'm coming. This is about, let me say 25.84. I'm coming, let me confirm. Yeah, 20.84. Exactly, 20.84. That's the mean. XB bar, that one will give you 22.18. That's our mean. Now, after getting the means, the next one is to go get their standard deviation and their variance, SA square, and that's the summation x minus x bar square all over n minus 1. So that will give me 52.84. Sorry, 52.94. When we use calculator to get their variance, this is what we have. And for the second one, SB square, same formula, x minus x bar square all over n minus 1, and that will give me what? 35.94. Now, we have gotten that one. So after getting your variances, remember, we want to know, what type of T are we using? We don't know. So find the ratio of their variance. So we want to find the ratio of variances. Don't forget, the larger variance will be up and the smaller variance will be down. If you observe, the ratio is less than 3. If you find their ratio is less than 3. So since it's less than 3, we are using what? The pooled T test. The pooled T test. And that is what? If you are using your pooled T test, the formula for your test statistics is XA bar minus XB bar all over the full standard estimate of the standard deviation, square root of 1 over NA plus 1 over NB. To get this, you must get your SP first. And your SP is what? NA minus 1 square NA minus 1, then SA square plus NB minus 1 SB square all over NA plus NB minus 2. You see what you have below here? This is the degree of freedom of the two samples. Remember, to get the degree of freedom of one sample is n minus 1. Of another sample, n minus 2. So altogether, it's like having NA plus N, sorry. The first one is n minus 1, the second one is also n minus 1. So altogether, you are minusing 2. All right. So from here, let's solve. If you solve this thing, I have everything here already. Your variance is here. The number of samples you have, how many are they? If you look at the number of samples you have, you will see 1, 2, 3, 4, 5. 5 samples. So if you put it there, you'll be getting this to be 44.45. Go and verify all these things. Then square root of 44.45, and that will be giving you what? 6.67. Good. Then from here, you can get your test statistics. And what are test statistics? C is equal to SA minus XB all over SP square root of 1 over NA plus 1 over what? NB. So I've gotten my SP already to be this. Always make sure you take the square root. I remember I always make that mistake sometimes like that. So take the absolute value, so you just get positive answer. So your answer here will be 4.216. That is it. Now I've gotten my TS already. Are you following?
Yes, yes.
So I've gotten my TS already. Now the next thing, after getting your TS, the next thing you have to get is the critical value of your T. We want to get what? The critical value of what? Of T. And don't forget, what is my degree of freedom? The degree of freedom is NA plus NB for the two samples minus 2. Now what would that give me? 5. How many samples do I have?
5.
5 plus 5 minus 2, and that's equal to 8. And our alpha is 5%. So let's go to our table to get the critical T. Let's go to our table to get the critical T. Now look at this. Now check. These are 5%, and what we are looking at says what is this 6 that is there. Sorry, our degree of freedom is exactly. So just trace this. What do we have?
2.306.
Exactly. These are our critical T. These are T critical. That's 2.306. Nice. 2.306. So our critical T is what? C critical is plus or minus 2.306. Now check. Does this value exceed this value? If you check, if you look at this, this is your critical T. If you check this value, it has entered this value. Yes or yes? It has exceeded, it has entered this rejection region. So what do you do?
We are going to reject null.
Exactly. You just say what? Therefore, we reject null hypothesis. We are rejecting null hypothesis. Why? This our critical T enters this rejection region we are having here. It has exceeded this value. Exactly. So we reject null hypothesis. So what do we now say? What do we now say? Now let us go back to the beginning of the survey. We are rejecting null. So what do we say? We will say, we can say there is no enough evidence to support this null. That's why we are rejecting it. Are we together?
Yes.
So how do you say what? There is not enough evidence to support that the two fertilizers are the same. The two fertilizers have the same effect on the plant, something like that. Are we together?
Yes.
Or you can say there's not enough evidence to show that the two fertilizers are the same on their level. So let me help you write it. So you say, therefore, there is not enough evidence. There is not enough evidence to support that the two fertilizers, that's our two fertilizers A and B, are the same on their level. I think that what they ask us in the question. That is, are the same on their level, exactly. Are the same on their level. Good. For me, I like to include this thing. At 5% significance level. Exactly. Then that's a. So this is 2, 3 tests. So that's our answer. Do you get that?
Yes.
So that's it. Now, that's one sample and 2 sample. Now, the last thing for you to just think this thing about how do you do F-test? Well, this one, let me just do one small example to explain that F-test for you. Because there's one long question like that. That's the last question in your manual. It's very long. That one consists of both T and F inside it. Probably in my leisure time, I'll try to solve that one. But let me just use this one as to explain how they usually do F-test for you. So for our F-test, pay attention. We use F-test whenever we are doing what? Whenever we are comparing variances altogether.
Yes.
In fact, we also use F-test when you compare more than 2 mean. If you are comparing 1 mean, T-test. 2 mean, you can also use T-test. But more than 2 mean at times, a lot of tests, but don't worry. I'm only focusing on this part. So sample 1, it's just like a straightforward question just to explain it. Sample 2. Let me say this sample 1 is 8. I have 5, I have 3. I have 5, I have 3, I have 17, 7. What do you have again? 17, 7. 17, 7, 16, 5, 13, 12. All right. 8, 5, 3, 17, 7, 16, 5, 12, 13, 12. Okay. And this one we have 12, 9, 16, 18, 18, 17, 12, 14, 12, 14, 18, 14, 17. Here we are. Please, I want to confirm something. Yeah, okay, this is how it looks. This is. So if you observe what I want to do here now, check. Our N1 is equal to, count it, how many do we have? Are you following? Are you still here?
Yes.
Our N1 is how many? 9.
Yes, 9.
Our N2 is how many? 11.
Yes.
So now, see how we do F-test. Firstly, what's my standard deviation, my variance? My variance, S1 squared. If I know, I'll find everything here already. So as to save time and to make the class less hectic. Because if you do this thing in life like this, you will have been tired by now. So pay attention. This form, the way we write our null and alternating hypothesis, this is how we do it. Our null hypothesis, we always say their variances are equal. This is like I'm using mean. If I want to say, for T-test, I'll say mu1 equal mu2. But for F-test, we are comparing variances. So I'll say variance 1 equal to variance 2. And the alternative hypothesis that what this is not equal to this. They are not equal to each other. Now, after that, we will find the F ratio, which is something as what larger variance over smaller variance. And what would that give me? 3.614. And pay attention, what's the degree of freedom? My degree of freedom, I have n minus 1, and that's 8. My degree of freedom 2 is what? 11 minus 1, and that's what? 10. These are different numbers. This is 11, this 9. Okay, I've gotten the F ratio. The degree of freedom, I've gotten it like that. All right. So remember, our alpha is always assumed to be 5%. Even they not tell you, assume 5%. Exactly, assume 5%. Whereby alpha over 2 will give me something like 0.025. That's 2.5%. Okay. Let us find our critical F. Please write these values down. Our degree of freedom.
Yes.
You can see that this numerator, is degree of freedom is 8. Our denominator, the degree of freedom is 10. Don't forget, okay?
Yes.
It's useful in our, so jot those values down. Yeah, let's go to our start table. Okay, come in. Now, here we are going to the F table. Now, we are looking at the F distribution. Now, don't forget to see what is the degree of freedom for the upper one, numerator. What degree of freedom? This B1. What is it?
8.
8. Good. So we are looking at 8 here. For denominator, what degree of freedom?
10.
Oh, yeah, where did they meet?
They meet at 3.07.
Hey, wait. So is that 5% significant level, Abina?
Yes, yes.
Come on, let me look at this one. There's something I'm checking. Yes, legit. Come on, I want to say something. Wait, this is the upper one. Yeah, it's correct. Yeah, let's go. What do we have? 3.07, Abby?
Yes.
3.07. Thank you. So therefore, we say our F critical from table, our F critical is what? 3.07, Abby now?
Yes.
Now, check what we have here. I have 3.614 and I have 3.07. What do we do?
We reject null.
We what?
We reject null.
Exactly, reject null, exactly. Why? Because this guy has this one that we have here. It has what entered this region. Yeah, it's greater than this, so it will enter the region, and that is it. Yeah, so that's how we find the F table. So numerator, denominator, yeah. So that's that for that. So we are done with everything about this hypothesis testing. So our next topic will be confidence interval. Then from there, we'll now be looking at all those blocking. Because those ones really come out in exam, all those ANOVA table. After ANOVA table, what else again? ANOVA, the ANOVA full of them. Two-way ANOVA. That's where the main work starts from. Don't worry. Make sure you practice all these ones very well. Okay?
Yeah, all right. There's no problem. Thank you.
Okay, no matter. Okay, now bye. Take care.
Okay, bye-bye.
Yeah.